We have just spent an entire program showing you how the behavior of light can be explained as long rays of particles that usually travel in straight lines. So straight that you can predict exactly where it will go after it reflects off a mirror or passes through a lens. Now we're going to show you that this is not always true, for sometimes light acts like an electromagnetic wave, which among other things can bend around corners. A shadow is usually directly behind an object, but look carefully at the edges of this shadow. The needle has a sharp edge, but its shadow does not. If some of the light has spilled into the dark area, could it be that light has bent around a corner? Here's another puzzling case. When light passes through a 1-inch slit, it makes it straight through to the other side. But if the slit is extremely narrow, the light produces a pattern. A pattern of light and dark bands. The only way to explain this peculiar property of light is to describe light as a waveform. Just as we used billiard balls to visualize and explain light rays as particles, we use water waves to visualize electromagnetic light waves. It's nice that they behave in a similar way. When water waves pass a sharp edge, they will bend around the other side. Similarly, light waves bend around a needle edge to create a fuzzy shadow. Water waves also spread out on the other side of a small opening. Light will do the same thing. This is called diffraction. The pattern produced when light diffracts is caused by the interaction of the light waves. We saw in our unit on waves and vibrations that waves interact with each other constructively and destructively. When two crests meet, they cause a larger crest, constructive interference. When a crest and a trough meet, they cancel each other out, destructive interference. If light is thought of as a wave, exactly the same phenomena should take place when light waves interact. When constructive interference happens, a bright band of light appears, just like an extra high water wave. When destructive interference happens, the light waves cancel each other out, so there's no light, a dark band. We've seen in our unit on radiation that different colors of light are different wavelengths of the electromagnetic wave. Diffraction can be used as a tool to separate light into its component colors, because each color will diffract a different amount. A diffraction grating is simply thousands of very small slits very close together. When light is passed through the slits, the different colors become visible. In this case, the 4 different colors of a krypton ion laser follow 4 different paths out of the diffraction grating. This is a very precise way of determining exactly what colors are contained in any particular beam of light. Astronomers use diffraction gratings to analyze starlight. Every star has a different color spectrum, a signature that depends on the type of gases and the temperature of the gases burning within the star. In industry, chemicals can be analyzed by burning them and then examining the color of the flame. Every substance burns with a different spectrum of colors, like a fingerprint. This device is an atomic spectrophotometer. It uses a diffraction grating to separate the colors of the flame into its different components. The composition of almost any substance can be determined using light as a tool. Light waves are extremely short, less than 1/1,000,000th of a meter long. Because of that, they can be used to measure extremely small things. Suppose you wanted to make sure that the surface of an object like a mirror is precisely the right shape. If a light beam, usually a laser beam, is reflected off the object, then compared to a reference beam, the resulting interference pattern, called a hologram, shows irregularities in the surface down to a few wavelengths of light. That kind of accuracy is extremely difficult to measure by other means. The same technique can be used to see how an object changes shape when under stress. Before and after images are compared, and the interference pattern shows the deformations caused by the stress. Those who put their lives in the hands of technology feel more confident when they know that the materials of that technology will stand up to the job because they've been tested and examined in fine detail by precision light waves.
Wow.